So a little 3.1 review. So 3.1 talks about quadratics. So we had x squared equations. So whenever we have an x squared, we're going to have two answers. So how can I get rid of that s squared? I square root both sides. Somebody watch the video. So to get rid of the squared, we square root both sides because it'll cancel out. So then we're just left with s on the left side. And on the right side, we take the square root of 144, which is 12. But we have to remember, anytime we take the square root of both sides of an equation, we need to include that plus or minus. So this is every single time we take the square root of both sides. So I'm going to make a little note here. Don't forget the plus or minus. All right, let's look at 15. So what can I do here? We never, ever, ever distribute the squared. If I had z minus 6 squared, it's like z minus 6 times z minus 6, and how would I multiply those together? We would FOIL if we had two things being multiplied. We don't distribute the squared, but FOILing would make this a little bit more work for us. How can I get rid of the squared? Same thing we did in the last question. We just take the square root of both sides. So square root both sides. That'll cancel out with the squared, and I'm just left with what's under the square root, so z minus 6. What is the square root of 25? Just 5? Plus or minus 5. Anytime we take the square root of both sides, you need that plus or minus. Am I done yet? No, I need it to be z equals. I need to get it all by itself. So here, technically I have z minus 6 is equal to positive 5, and z minus 6 is equal to what? Negative 5. So when I have a plus or minus a whole number, I'm going to split it up into two equations and then just solve. So here I just have two little equations. I have one last step. What can I do to solve? Add 6 to both sides. So z is equal to 11. And then second one, I'm going to do the same thing. Add 6 to both sides. So z is equal to 1. So these are my two answers here. So 17 is kind of similar. It's just a couple more steps that we have to do. So just like the last one, I want to get this squared part all by itself first. So what do you think I need to do first to get that all by itself? Before I square root it, I have to get it alone. Not going to distribute because I can't distribute the 4 in there if it's squared. Definitely can't do that. How can I get the x minus 1 squared all by itself? Before I divide by 4, what else could I do? Subtract 2. I want to move that 2 to the other side. I want to move the 2. Notice what's not highlighted on the left here. I want to move the 2 and the 4 to the other side. So I'm going to subtract 2 to get that 2 over. So I have 4 times x minus 1 squared is equal to 10 minus 2 is 8. And then again, I want to get what's in the parentheses all by itself. So since 4 is being multiplied to it, I want to divide both sides by 4. So now I have x minus 1 squared is equal to 2. Now that my x minus 1 squared is all by itself, how can I get rid of the squared? Square root both sides. So it'll cancel out with the squared. So on the left, I just have x minus 1. What do I have on the right? Yeah, because I don't know what the square root of 2 is, but what else? Plus or minus. So plus or minus square root 2. So if I could solve this, if I knew what the square root of 2 is, I would just make it the whole number, just like I did with the square root of 25. I simplified it to 5. But here I don't know what the square root of 2 is, so I can just leave it. Can't be simplified anymore, so we just leave it like that. And then what's the last step? Remember, I want it to be x equals. The x has to be alone, so what can I do last? Add 1 to both sides. So I have x is equal to 1 plus or minus the square root 2. So 47. To solve, we can get rid of this g of x and just make it 0. Sometimes it'll say g of x, sometimes it'll say y. We just make it 0. Because we're trying to find what x is equal to. So how can I solve for x here? Factor. Awesome. We want to factor. So if I have an x squared and an x term, you always want to factor. In order to factor, it has to be equal to 0 to start. So it has to be equal to 0. So that was like the main point that I talked about in the video. And again, if we don't remember the video from 3.1, make sure you watch it. So how would I factor this? Awesome. So our two factors of 8 that add to 6 would be 2 and 4. So we would write it as x plus 2 and x plus 4. And it's equal to 0. Now here we're not just factoring, we need to solve it all the way. So what can I do next to solve? If we FOILed, we would end up with the original question. So we're trying to break it down. Awesome. We set each parentheses equal to 0 as our own little equations. So x plus 2 is equal to 0 and x plus 4 is equal to 0. So we just break these up into two little equations and solve. So in my first equation, x plus 2 is equal to 0, how would I solve that? I subtract 2, so what does x equal? Negative 2. And in the second one? Awesome. Subtract 4, so x is equal to negative 4. So those are my two answers. So 3.2 deals with complex numbers. So when we have complex numbers, it deals with the imaginary unit I, imaginary. And how we get that I is whenever we take the square root of a negative number, so the square root of negative 1 is I. So we don't like to take the square root of negative numbers because they are imaginary, but now we're learning about imaginary numbers, so we can go ahead and take the square root. We just turn it into an I.
It doesn't have to be 1, it could be like -2.
Yeah, we'll do some examples where it's not 1 and we have numbers, and I'll show you. Another important thing to know is whenever we have I squared, that turns into negative 1. So when you square the imaginary unit, it turns into a real number. So this will come in handy in the second part of the notes towards the end of today. So these are two important things to know. All right, so let's do some examples. So here we have to find the square root of each number. So the first thing we want to do when taking the square root and there's a negative under the square root is we want to take it out and turn it into an I. So we just got rid of the negative from under the square root. So you just take it out, make it an I. Now what's the square root of 25? 5. So my answer here would just be 5i. The I goes after, it's like a variable, so it's like x. We never say x5, it's always 5x. So it just goes at the end of the number. All right, let's look at B. So what's the first thing I want to do here? Take out the negative, and what does it become? An I. Now I want to simplify the square root of 72. 72 is not a perfect square, so we have to break it down. What are two factors of 72? 8 and 9. What are two factors of 8? 4 and 2. And two factors of 9? Can I break anything down anymore? 4 gets broken down into 2 and 2. So we did this in, I think, R2. So that's why we reviewed, because it comes back. So what would I circle here?
So there's 2 3s and there's
2
2 2s.
2s and 2 3s. So what comes to the outside? The 2 and the 3. So everything that got circled comes to the outside, but it's just one. So a 2 comes outside, a 3 comes outside. What am I left with on the inside?
2 in the outside.
The 2 that stays on the inside. Where did the I go?
The inside. Or is it on that?
I took it to the outside. The I goes on the outside. And then lastly, what do I do if I take out more than one number? What do I do to those numbers? Multiply them. So this would be 6i square root 2. So the I comes after the whole number, but before the square root. So if you are writing your answer and it has all three, a whole number, an I, and a square root, it would have to be in this order. Because we wouldn't put the I after the square root because it might look like it's part of it. So we just put it in front. All right, let's do C. So what's the first thing I should do here? Take out the I and take out the negative and turn it into an I. And then what's the square root of 9? 3. So I have negative 5i and 3. But can I combine any of these together? Negative 5 times 3 would be? So negative 15i is my answer. So all of these are just being multiplied together, so I can multiply the 5 and the 3. So when it's a perfect square, so a number like 9, 25, 36, 49, numbers that are perfect squares, you don't have to break them down if you know what the square root is. If it's not a perfect square like 72, that we would want to break down. Any questions here? All right, we're going to look at 3 and 4 on the next page. So looking at number 3, what would I do first? Take out the negative, and what does it turn into? An I. So we already have a negative, so it's a negative I on the outside. And what's the square root of 36? 6. How would I write my answer here? Negative 6i. Perfect. So the negative always goes out front, and the I would just be last. And lastly, let's do 4. What do I do first?
Take out the I.
Take out the negative and turn it into an I. Now, is 54 perfect square? No. So we got to break it down. What are two factors of 54? 6 and 9. What are two factors of 6? 3 and 2. And two factors of 9? 3 and 3. So what would I circle? 3 and 3. Why can I not circle the 3 3s? It has to be a pair. So pairs of 2 of a kind. So what's going to come to the outside? The 3. I already had a 2i on the outside. Now I have another 3. And then what stays on the inside? I'll fix it at the end, but yes, it matters. So the 3 and 2, whatever I didn't circle stays on the inside. So 3 and 2. Now if I have more than one number on the outside, what do I do to them? Multiply. And what if I have more than one number on the inside? Multiply. So how would I write my answer here? 6i square root 6. Perfect. So it matters where we put the I. We just put it at the end of the whole number, right before the square root. I have a pair of 2s. No, it doesn't have to be. If there's 2, you circle them. I just rewrote the 2 here, but I could have circled like these 2. I like it when all my pairs are in line. That way I don't have to look for them. Questions? Okay. All right, so a complex number can have a real part and an imaginary part. So whenever we write a complex number, the real part has to come first. So if I had something like 5 plus 2i, are these like terms? No, one of them has an I and the other one doesn't. So I wouldn't be able to add them together. So I would just leave it like this. But when I write my answer, the real part has to come first and the imaginary part comes second. These are not like terms we cannot combine. All right, so next we have the equality of two complex numbers. If I had a complex number was equal to another complex number, then I know that the real parts are going to be equal to each other. So this says A and C are equal. And then the imaginary parts, the parts with the i's, are going to be equal to each other. So B and D. So whenever we have an equation like this, where it's a complex number is equal to a complex number, I just need to set the real parts equal and then the imaginary parts equal. So I make my own two little equations here and solve them separately. So looking at our example 2 here, what are the real parts? 2x and 10. So I would say 2x is equal to 10. Now how can I solve for x? Divide by 2. So what does x equal? 5. So there's one of my answers. And then I need to look at the imaginary parts too. So what are my two imaginary numbers here? Awesome. Negative 7i. So it's not just a minus. It sticks with the 7. So negative 7i. And yi. So negative 7i is equal to yi. Now my goal here is to solve for y. So how do I get the y all by itself? I can divide both sides by I, so they cancel. So what's y equal to? Negative 7. So we just set the real parts equal, solve it. Set the parts with the i's equal, solve it. All right, we're going to do 2 more just like that. So what are my real parts for number 5? X and 9. So I would say x is equal to 9. Do I have to do anything to solve that one? Nope, solved. Done. Now what are my imaginary parts? 3i and negative yi. So 3i is equal to negative yi. Now again, I want to solve for y, so how do I get y all by itself? I can divide by, let's do one step at a time, but you could do them both together, that's fine. I'm going to divide both sides by I, so they cancel. So I have 3 is equal to negative y. Now y is not all by itself, so I'm not done yet. How do I get rid of the negative? Divide by a negative 1. Or just flip the sign. That works too. So y is equal to negative 3. So I'm writing out each step, but in the beginning, if you have 3i is equal to negative yi, you could just cross out the i's. If you have 1 on both sides, you can just cancel them, which is just what we're doing. I'm just dividing it out, but it's the same steps. Any questions here? All right, let's look at number 6. What are my real parts? 9 and negative 2x. So I'd say 9 is equal to negative 2x. Now how can I solve for x? Divide negative 2 on both sides. So what does x equal? Negative 9 over 2. We can just leave it like that. Now what are my imaginary parts? 4yi and 3i. So what can I do first to solve for y? Divide both sides by I, so they'll cancel out. So 4y is equal to 3. And then what? Divide both sides by 4. So don't be afraid to get fractions. So y is equal to what? 3 over 4. Right. We can also add, subtract, and multiply our complex numbers. It's just important that we add the real parts and the imaginary parts separately. So you have to do it separately. So we add the real numbers together, add the imaginary parts together. They are not like terms, so we can't combine a real number with an imaginary number. So when we add, we have to do it separately. So looking at 8, I'm adding here. So I could just get rid of the parentheses. What are my real parts? So what's 9 minus 6? 3. And then what are my imaginary parts? Negative I and 7i. So what's negative I plus 7i? Awesome. That negative I is just like saying negative 1i. Our coefficient here is 1, just like if we had a negative x. So it would just be 7 minus 1, which is just 6, so 6i. And then just like I mentioned before, we have to put the real part first, the imaginary part second. What do I need to do first to solve for 9? Awesome. We want to distribute the negative first. So that gets distributed to both things after. The first parenthesis stays the same, so 3 plus 7i. And it becomes minus 8. And what's negative times negative 2i? Positive 2i. Perfect. Now we want to combine our real numbers first and then our imaginary. So what are my two real numbers here? What's 3 minus 8? Negative 5. What are my two imaginary numbers? So what's 7i plus 2i? 9i. All right, and let's do 10 also. What should I do first for number 10? Distribute the negative. Just that one? I have to distribute the other negative too. So if there's a negative in front of the parentheses, it gets distributed to whatever it's touching behind. So I have negative 4 minus 1 minus I and negative 5 minus 9i. Now let's start with our real numbers. What are my real numbers here? Perfect. Negative 4, negative 1, negative 5. So it's negative 4 minus 1. Negative 5 and negative 5 minus 5. Awesome. Negative 10. And then my imaginary numbers, I have negative I minus 9i. What would that be? Perfect. Negative 10i. And just don't forget, we have to put the real part first, the imaginary part second. So when we multiply, we just have to keep in mind that if I ever have an I squared, it is negative 1. So if I have an I squared, I want to change it to be negative 1. Bless you. So looking at A, how can I multiply these together? Distribute. So I'm distributing the 4i to both things inside the parentheses. So what's 4i times negative 6? Awesome, negative 24i. So we just multiply 4 times negative 6, which gives us negative 24, and the I just stays there. Now what is 4i times I? Awesome, 4i squared. Since I have an I times an I, that turns into I squared. I squared turns into what? Negative 1. So this is like saying 4 times negative 1. What's 4 times negative 1? Negative 4. So I can change that 4 to become a negative 4. So whenever you have an I squared, it just changes the sign of the number that it's behind. So the number in front of it, we just change the sign. So instead of a plus 4, it's a minus 4. Now are these like terms? No. So I can't combine them, but am I done? No. What do I have to do next? I got to switch the order. So the real number has to come first, then the imaginary part second. So negative 4 minus 24i. So the real part has to be first. All right, looking at B. How can I multiply these together? Awesome, our favorite F word, FOIL. Other than factor. We like factoring too. But we want to FOIL. So I start by multiplying the first ones. So 9 times negative 4 is negative 36. Then I multiply the outsides. 9 times 7i, 63i. Then the insides, what's negative 2i times negative 4? Positive 8i. And then the last ones, what's negative 2i times 7i? Negative 14i squared. Whenever you have an I times an I, it turns into I squared. And what does the I squared turn into? Negative 1. So what does that change the? Awesome. We make it a positive 14. Yes.
Okay, so this, do you have to change it in size or positive?
So since our answer has to be real numbers first, let's combine our real ones. What is negative 36 plus 14? Negative 22. And what are our imaginary numbers are 63i and 8i. So what's 63i plus 8i? 71i. And that's our answer.